Let's look at section 4.3, mixed and entire radicals, and let's take a look at the basics. Here we're going to convert an entire radical into a mixed radical. Right. Now it's important that you have your list of perfect squares. 1, 4, 9, 16, 25, 36, 49, so on and so forth. You have your list of perfect squares somewhere, and you have your list of perfect cubes somewhere as well. 1, 8, 27, 64, 125. Keep those numbers handy. Now what we have here is we have square root of 20. That is an entire radical. We are going to try to convert it into a mixed radical, following a series of steps, a certain algorithm. What we do is we take a look at 20, and we think to ourselves, what are the factors of 20? Well, 1 and 20, 2 and 10, 4 and 5. We look for factors where one of the factors is a perfect square. So we see if we can divide 20 by any perfect square. We can divide 20 by 4. So we rewrite 20 as the square root of 4 times 5. Right, that just makes sense. We just broke 20 up into two numbers. One of those numbers is a perfect square. Now, using our rule that we learned before about the multiplication of radicals, we can split this apart. This becomes the square root of 4 times the square root of 5. Just broke it apart. Lastly, we know what the square root of 4 is. It's 2. And we still have the square root of 5. This is now a mixed radical. We just went from an entire radical to a mixed radical. What we did there was we made something called the simplest form of the radical. So the square root of 20 in simplest form is 2 square root 5. All right, so let's take a look at the cube root of 16. Now we're dealing with cube roots, so we're going to want to deal with our perfect cubes. We have to think to ourselves, what can I break 16 down into, factors-wise, where one of the factors is a perfect cube? I can deal with the 8. I can divide 16 by 8. So I'm going to turn this into the cube root of 8 times 2. 8 being my perfect cube. Then I break it apart into two cube roots. The cube root of 8 times the cube root of 2. Lastly, I can take the cube root of 8 to get 2 times the cube root of 2. This final form is our simplest form of the radical. The cube root of 16 is equal to 2 times the cube root of 2. Now remember, I've told you in math, when you learn how to do a process in one direction, you always have to learn how to do it going backwards, going the other way. So we're going to convert these mixed radicals into entire radicals. Now the first thing that we need to note here is about the 2. I just want to note on the side, 2 is equal to the square root of 4. This is an important fact here. Because we're dealing with an index of 2 in this radical, we want this fact here. So our 2, we can change that into the square root of 4, because our 2 simply becomes the square root of 4. Now if you remember, this mixed radical, 2 square root 3, is the same thing as saying 2 times square root 3. So this now becomes the square root of 4 times the square root of 3. Now I can combine those two to get the square root of 4 times 3, which then becomes the square root of 12. Basically, another way to think about it is to get this 2 to go under the square root sign, I had to square it. All right, let's take a look at this one. Now we've got 3 times the cube root of 4. Now 3 is equal to the cube root of 8. So to get the 3 under a cube root sign, no, it's not equal to the cube root of 8. Not even close. It's equal to the cube root of 27. To get the 3 under the cube root sign, I had to cube the 3. So I take this 3 right here, and I replace it with the cube root of 27, because those two things are the same. And I still have this cube root of 4. Now, because these both have the same index, I can just combine them together. The cube root of 27 times 4. And then we can multiply 27 by 4, and we are going to get 108. So 3 times the cube root of 4 is equal to the cube root of 108. Usually we don't work this way backwards. Usually we work from an entire radical to a mixed radical. All right, so let's take a look at our last basics, simplest form. The question asks you for simplest form, or to simplify, it means converting it into a mixed radical. So our first one, 8. I need to think of a perfect square that I can divide 8 by. Right, because this is square root, so I look at perfect squares. So perfect squares, square root of 4 times 2. That's my perfect square. Then I break it apart, square root of 4 times the square root of 2. The square root of 4 is equal to 2, so this becomes 2 square root 2. That is simplest form. Now we're going to do the cube root of 54. Now I have to think about my list of perfect cubes. What perfect cube can I divide 54 by? And in this case, that's 27. It's 27 times 2. 54 is 27 times 2. So I rewrite as 54 is 27 times 2, where 27 is my perfect cube. And I break it apart. The cube root of 27 times the cube root of 2. And the cube root of 27 is 3, so this becomes 3 times the cube root of 2. This is now in simplest form. All right, thank you for watching. If you have any questions, put them in the comments below.